Let's go through equals 315 count of smaller numbers after itself. For this question, it gives us an integer array nums. And for it, let's count the numbers of smaller number for every element on its right. For example, 5 on its right, there is 2 and 1, which is smaller than 5. So there are 2 elements. So the count is 2. And 2 on its right, there is only 1, right? 6 on its right, there is 1. And then 1 on the right, there is no element. So this is the return result. For this time complexity, if we do brute force, right? Brute force, that is, we just compare use to follow, it will be O n square time complexity will be TLE. So what we think about that is we should have some kind of n log n time complexity algorithm, right? So intuitively, and there is one way like the sorting, right? We can go to the sorting direction to solve this question. And for this question, we also can do doing this by merge sort. And if we have these nums already being divided to divide to different smaller ranges, right? So if this is already sorted and this is sorted, right? So if we have an index I, right? And also on this right, if we find an index j, which is the largest smaller than I, then let's say this kind of elements will all contribute to this kind of nums I, right? So what we do is that we need to have a count array, right? Count array to have our result. But the thing is that if we sort this nums array directly, and the order already changed, right? So we, for the counts of index I, right? So what we think about is that instead of sort these nums, we can sort the index directly, right? So we do not have this nums array to be untouched, but we have index array to sort this one. And for the value, we just use this nums as a map, right? And then in this case, and the counts, we can also goes to the index array, right? To have every time we just have a count index to add this kind of range. So after doing this kind of analysis, let's write code. So we'll have int n equals nums dot length, and we'll have int count array as our result, and count array as our result, new int n, and we'll have int id arrays. We sort this id array, new int n. And we are have initialize this one for int I equals to 0, I smaller than I plus plus, and we have IDs I equals I. And we have a temporary, right? Temporary equals new int n. And we have merge sort. This is the original array. We don't want to change it, IDs and temp, right? So now we pass in those counts array as a reference, right? And 0 in the start and end. And after doing this merge sort, then we have our update counts array, right? What we do is that we result this integer result equals new array list. And we should have for int count in counts. And we have result add count, and then return result. Next is that we need to have the void merge sort. So for this one, we are passing nums, passing IDs, passing temp, and passing this counts, right? And passing start, and passing end. So we'll say if this is start greater equal to end, then return with nothing, right? And then we have mid, in the mid equals to start pass and minus start divided by 2, right? So we have merge sort nums, IDs, temp, pumps, start, the mid. And also we need to merge sort from mid to mid plus 1 to end, right? And we should merge nums, IDs, temp, pumps, start, mid, end, right? Let's write a merge function, private void merge. So we have int nums, int IDs, int temp, int pumps, int start, int mid, int end, right? And we have int left equals start, right equals mid plus 1, and I equals start, right? So while left is smaller equal to mid, and right is smaller equal to end, right? Now we'll say if because we are merge sorted IDs, right? And we need to compare the value. So we should have nums IDs left smaller equal to nums IDs right. In this case, we're going to have temp I plus plus equals IDs left plus. If we move the left pointer, right? Else we're going to have temp I plus plus equals IDs right plus plus. Here, when we move the left pointer, right? That means this kind of right pointer is just is one index outside of the is, so the right is just move outside. In the previous or in some of the previous round, just moved outside of the range, right? So that means as long as the right stops, right? So for the for this part, right? M mid plus 1 to right minus 1, right? It will contribute to this kind of left. So when we move the left pointer, then we need to add the counts to this left pointer, right? So we can update our counts here, right? So what do we do is that we have counts IDs left equals right minus mid minus 1, right? So this is actually right minus 1 minus mid plus 1, right? And then minus 1, right? Right minus 1. minus right. Um, right plus one, right? Plus one. Let me see. Mm, need to move. Ah, uh, minus one. So this is this is minus one and plus one, right? Because the right is just outside the range, right? It's just right outside the range, right? So we'll say mid plus one to right minus one is what we need to contribute, right? And these are all inclusive and should add one, right? So this right, this is exclusive. So this will be right minus mid minus one, right? If we are not sure about this index, right, you can add doing something like a right count equals to 0, and when we move the right, we have a right count plus, right, and here instead of add this kind of formula, you just add add a right count, right? So this should add to, because in the next merge, it will also contribute this to count array, right? So you can also add this one, add equal to right count, right? So this is another way. If you not sure about this index, right? You can write a right counter, right? And if the left is not finished, we are going to have the count index left um, to add equal to still the right minus the minus one, right? And also you can use the right counter and add equal to right constant. And then we should have temp I plus equals IDs left plus. And if the right is not in, right haven't finished, then we're going to have temp. This one does not contribute to the counts, right? It's just update our temporary IDs, right, plus. And after this merge, we need to copy back this kind of index to from temporary to our index array, right? Int k equals start is smaller equal to n k plus plus. So what we do is that we are going to have index k equals temp. So this will be the code. It's n log n time complexity. And let's convert this to Python code as well, right? Let's write a Python one. So we're going to have n equals length nums. And we are going to have counts, temp, and the IDs equals, for the counts, it's this one multiplied by n. And temp is also this one multiplied by, right? And for IDs, it is list of range, right? Okay. And we need to have merge sort nums, IDs, and the temp and counts, and 0. This start and end, right? And we return counts. Then we define the merge function, the merge sort function, right? So we should have nums as list of int, and we should have IDs as a list of int, and we should have temp as a list of int, and we should have count as a list of int. We should have start as int, that have end as int, right? So what we do is that we put start greater equal to end, return. Then we should have merge. Let's have mean equals to start plus end divided by 2, right? And then we have merge nums, IDs, temp, counts, start, mid, and have mid plus 1, mid plus 1 for end. And then this is not merge, should be merge sort, right? Merge sort. Then we need to have the merge, right? Merge start mid to end, right? We didn't define the merge function, right? Let's define the merge function. Df merge, right? So for the merge, we need to have one more parameter, that is the mid. We have mid as the int, right? So for merge, we have left, right, I equals start mid plus 1 and start, right? So we'll say while left smaller equal to mid, and the right smaller equal to end, right? So we'll have counts. We because we every as long no, we need to compare if nums IDs left is smaller equal to nums IDs right. In this case, we're going to move the left pointer, right? So we'll have counts IDs left, which the add equal to right minus mid minus 1, right? And we'll have temp I equals IDs left. And we show the I plus equal to 1. And we should have left plus equal to 1, right? Then we'll have else. Else for the right pointer, we don't need to contribute anything, right? Equals IDs right. And we'll have I plus equal to 1 and right plus equal to 1, right? And the left part pointer may not finish, right? So we'll have need. So what we do is that we still need this kind of code, right? And this is the left point and also right point, right? Wanna right smaller equal to n. So we should have this, right? This is the merge. And also after merge, we should copy from temp to our IDs array, right? For k in range. Start to end of +1, right? We're going to have IDs k equals temp k. Okay, so this will be our code. Yeah, as per I talk about, right? If you you're not confident about write this index directly, right? You can have another variable called write count. Initially set this one as 0, and we'll move the right pointer. We have write count plus equal to 1, right? Plus equal to 1, and this one just add right count, and also this one just add right count. Should be the same. Should have the same result. Okay. The time complexity is n log n spaces or